Designing a personal geodatabase. The session objectives. Understand designing a geodatabase. Understand different geometry types. Also, understand the different attribute types. Okay, steps to designing a good geodatabase. Start with a good data model. Data model is also known as a schema. Okay, this might require you to do some planning and even some revisions. Write your design down. Pass it around. Let others look at it. Let others have some input on it. Sleep on it for a while. A lot of the things that you do in the geodatabase design are set in stone. You can't go back and change. So make sure that what you want is what you have the first time. So you will have a geodatabase. Your geodatabase will contain a feature data set, or it can contain multiple feature data sets. Data sets contain feature classes. Feature classes will have geometry types. Each feature class will also have attributes. And each attribute has a data type. So there's a lot going on here. Let's break it down a little bit more. Okay. Feature classes contain geometry. What this means is you will have a feature class. It will either be a point, a line, or an area. A point. A point is a single geographical location. Okay, it doesn't have a length, it doesn't have a width, it just has one point. Some examples would be a fire hydrant, or a tree, or a power pole. Lines. A line is a series of geographical locations that are connected. A line has length but no width, and a line does not close. Okay, some examples would be roads, streams, or sidewalks. Areas. An area is a closed line. Okay, so it's going to have a length and a width. Some examples are parking lots, wetlands, lakes, or building footprints. Okay, so once you have a feature that has a type, it's going to contain attributes. Attributes answer questions about the feature. Some examples: who's the manufacturer of the hydrant? What is the width of the sidewalk? How many parking spaces are in the parking lot? Okay. Each of these attributes has an answer to it. So, who's the manufacturer of the hydrant? That's going to be a text, because you're going to want to be able to type in M-U-E-L-L-E-R. Or you could have a drop down. I'll go over that in a minute. So attributes have different types, different data types. Notice over in the gray, numeric, text, date, blob, and GUID. Numeric. Under numeric, notice there are 4 different kinds: short integer, long integer, single precision, which is known as a float, and a double precision, which is known as a double. Now, what determines whether something is a short integer or a double? It depends on if you want decimal places or not. Integers do not have decimal places. And then it really depends on how big of a number you want. Notice that the short integer is negative 32,768 to positive 32,767. So if you have a number, or if you have an attribute and the range is going to be in between these numbers, then you can use a short integer. If you have something that's going to be higher than that, without decimals, then you can go with a long integer. And then you have float and double. These are if you need decimal places. A float is a really, really, really large number. Okay, a double is a really, 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 really large number. If you notice, like scientific range is like a scientific calculation, because they're really large numbers. Generally, doubles are used like if you're using a coordinate system or something. Okay. Now, why does it really matter? Why does it matter if you choose a short integer versus a double? Well, if you look under size, you decide what data type the attribute is going to be. The data type determines what the size of the column, how much is it going to take up in the database. Space-wise, a short integer is only 2 bytes, where a double is 8 bytes. If you were to choose a double when you could have used a short integer, you have essentially quadrupled the size of that particular column in your database. The shorter or the smaller the database, the faster you can run things. So this is important to pay attention to. Now, if you ever think you might need a decimal, make sure that you go ahead and choose float or double. This is something that you cannot go back and change. Okay? Then you have text. Text can be alphanumeric. Okay? What you want to pay attention to, you would want to use numeric over text if you ever think that you're going to want to run calculations on something. So, for instance, if you're talking about pipe size, like of water mains, if you had them as text, you could not say, show me all the pipes 10 inches and larger. You would have to run a different calculation on that. So text is alphanumeric, so it can be numeric as well. However, you cannot run calculations on text. And then there's date. Date is, month, day, year, pretty much. Blobs or binary large objects. Those are generally images. They're ones and zeros, so you can't really see the image. And then there's GUIDs. Those are the global unique identifiers. Really, the main ones that we're going to be using are going to be numeric, text, and data. All right. So a little bit ago, I said always write down your schema or your geodatabase model. Pass it around, sleep on it, and all that. We're going to go ahead and write one down for practice. Okay, we're going to create a geodatabase, and it's going to be called My World. And in that, we're going to have a data set called infrastructure. Within infrastructure, we're going to have several different feature classes. We're going to have a point, which is going to be a light pole. We're going to have a point, which is going to be a point generic. A line, which is a sidewalk. A line, which is going to be called line generic. A polygon or an area as parking lot, and then an area or a polygon as area generic. So our geodatabase is My World, feature data set, infrastructure, and then the 6 different feature classes: light pole, point generic, sidewalk, line generic, parking lot, and area generic. Okay, we are going to create our database schema right now, our geodatabase schema. Okay, so I said we were going to create those 6 different feature classes. The first one is going to be a point feature, which is going to be a light pole. Now, what do we want to know about the light pole? What attributes do we want to have? We're going to have an ID. Generally, anything that you go out and GPS has an ID associated with it. And we're actually going to make this ID text, because you never know when somebody would potentially throw in a letter for an ID. And if you had it as a short integer, there's no way you could put a letter in there. So to be on the safe side, IDs are generally alphanumeric, so text is what you would want. We're going to have material. What is the material of the light pole? We're going to create a domain for this. We're going to create a coded domain. Okay, this is going to create the drop downs. We're going to have it be text, because we're actually going to have letters in there, and our different choices: wood, metal, fiberglass, concrete, and other. Our next attribute is going to be number bulbs. We're going to create a coded domain, and it's going to be a short integer, and our choices are going to be 1, 2, 3, 4, 5, and 6. And then if you notice, I have a -999. The -999 is going to be what's in the geodatabase, because it has to be a short integer. But everywhere we see -999, we're actually going to see the word other. So we're going to basically have a way, so if you have a drop down, a way to put in a value other than the 1 through 6. We're going to measure the height of the pole, and notice I put height _ FT. The person creating the geodatabase is not always the person out in the field collecting data. You might have multiple people collecting data. If you do have multiple people collecting data, who knows what unit of measurement they might put it in. So if you put an _FT, then it's pretty much set in stone. I want this in feet. We're going to have this be a range domain. So remember, a range is, you can have a number from here to here. You actually type in the number, and it has to be between a certain thing. We're going to have it be a short integer. It's going to be 20 to 100. Okay, so the short integers, no decimal places, right? I don't have an eagle eye, so I can't tell the difference between 25 and 25.2 feet. Okay, so we would just put in 25. Right, we're going to do condition. We want to know the condition of a poll. And once again, we're going to have a drop down. We're going to have a domain. It's going to be coded, and it's going to be text, and the choices are going to be good, fair, repair, replace. We're also going to put in a place an attribute for photo. We're going to have that be a text, and the way that photos are going to be handled is they're going to be hyperlinked. Then we're going to do comments. We're going to have that be a text as well. And then, last but not least, we're going to do date collected, and that's going to be date. So these are our different attributes for our feature class that is going to be light pole, and the feature type is, or the geometric type is a point. So we have a lot of stuff going on here. All right, our next feature class is going to be called point generic, and it's going to be a point. We're going to have comments, which is going to be a text. And then we're going to have date collected, which is a date. The next feature is going to be sidewalk, and it's going to be a line feature. We're going to want to know the sidewalk ID. Not all sidewalks have IDs, some do. This way, if we need to put one in, we will have an option of putting one in. Material. We're going to have this be a drop down, so that's going to be a coded domain. It's going to be a text. Concrete, asphalt, pavers, gravel, organic, and other. Why do I put other in there? Well, what if I come across some new type of material? They're actually making rubber sidewalks now, and I go out and, oh, it's rubber. Well, if I didn't have that choice in my drop down, then I could select other, and then in the comment section I could type in, material is rubber. We're going to want to type in the width underscore feet. Now notice this is a float. What is a float? A float contains decimals. I'll actually be able to take my measuring tape and measure the width of the sidewalk, and pretty precisely, and then I can put in the width. Condition. It's going to be a coded domain. Now we would have already created this drop down whenever we created the condition drop down under light pole, so we're not going to have to recreate that twice. We're going to create an attribute for photo, an attribute for comments, which is going to be text, and then date collected, which is going to be a date. The next feature class is line generic. Comments for text, and then date collected is going to be a date. We're also going to create feature class parking lot, which is an area, also known as a polygon, depending on what GIS or CAD system you're used to. We're going to have lot ID. Some parking lots have IDs, some don't. This way we'll have an option of putting it in if there is one. Material. Once again, it's going to be a coded domain. Now we've already created this. Whenever we created sidewalk, remember we did like concrete, asphalt, pavers, gravel, organic, all that. That is going to be the same material that we're going to use for parking lot. If you create a domain, you can use it across multiple feature classes. Number of spaces. It's going to be a short integer. I can't have 5.5 spaces, so it doesn't need to be a double or a float. Okay? And I doubt any parking lot's going to have more than 32,767 spaces, so that's why it can be a short integer. Number of handicap spaces. This can also be a short integer. Condition, we've already created it. Photo for the text is, and then comments is going to be a text, and date collected is going to be a date. Okay, and then this is going to be our last one, area generic. We're going to do comments as a text and date collected as a date. So those are our 6 feature classes with the attributes. Okay. When you design, there are a couple considerations you might want to think about. Like I've said, and I'm going to continue saying this, write it down, pass it around, talk to people. If there are other organizations around you that are doing something similar, you maybe want to call them up and see what they're doing, see what their schema is. Remember, schema is the database design. There are sample schemas out on the website at Esri's website. When you design your database, you might also want to have an attribute field called data source, and you could have it be a coded domain, and you might want to say something such as built, heads up digitized, CAD, surveyed, mapping GNSS, or unknown, so that whenever you actually look at the data and you're like, oh, where did this data come from? You'll actually be able to tell from the attribute table. You also might want to include a field of the field collector. So you could go in and have a coded domain that has the names of all the field collectors and out in the field. If Johnny's out collecting data and it says collected by, he would tap Johnny. So whenever you are looking at data, you will know who collected the data. So let's recap. Understand designing a geodatabase. Write it down, pass it around, sleep on it. A lot of things are set in stone. Understand different geometry types. There's the point, the line, and the polygons, also known as areas. Then understand the different attribute types. Numeric, remember there are 4 of them. Text, date. You don't really need to know blob or GUID. It's really just those the 3, the numeric, text, and date.